What is money? You can buy stuff with it. For example, you can buy a hamburger with a $5 bill, but money isn't just pieces of paper, because you can't buy a hamburger with construction paper. You can buy one with a plastic card, but the plastic card has no more intrinsic value than the paper did. You can't buy a hamburger with an empty soda bottle. What the credit card and the $5 bill have in common is they both stand for wealth that you have. But what is wealth? That's hard to define. About the best way to quickly define wealth is that it's the ability to make things happen in the economy. There's a lot of different things you can do with wealth in the economy. You can buy stuff you want, hire people to do tasks that you don't want to do, invest your money by letting someone else use it for a fee, and so on. And there are many ways that we can store our wealth too. Cash, bank accounts, securities like stocks and bonds, property like a house or land, and so forth. So wealth is a good metaphor for energy, but it's easier to get your head around because it's a little bit more common to people who are not scientific. So we're going to talk about it first, and then we're going to segue to an important physics concept called energy. Let's look at a way to model the wealth of one person, a single guy who has this wealth. He's got a checking account with $5,000 in it. He has a savings account with $30,000 in it. Those are both two kinds of bank accounts. Checking accounts are usually a little bit easier to get your money in and out of. Savings accounts are for like longer term storage of your wealth. Property, he has a car that's worth $7,000, and he has just some cash, some bills and things that add up to $500. The pie chart could be a good way to model this guy's wealth. So we have a big slice of the pie is savings, because that was the biggest way he's storing his wealth. A skinny little slice for cash, that's the little magenta one. Checking account is yellow, and his property, his car, is represented by the red slice. So the slices of the pie are proportional to how much of his wealth is stored in that particular mode. And the size of the whole pie, that's how big his whole wealth picture is. That's all his money is represented by the size of that pie. All right, pie chart is also used for modeling changes to this guy's wealth. So let's say that he's found a used car he wants to buy, and it's worth $12,000. He needs $12,000 to seal the deal. To prepare for that purchase, he transfers $12,000 from his savings to his checking account, so it's a little bit easier to access. Now, the total size of his pie doesn't change. His total wealth is still the same, and in fact, two slices of his pie are unchanged. The cash and the property don't change at all. But two things do change, and one of them is that his savings will get smaller, and the other one is that his checking will get larger. So total size of the pie didn't change, but the changing pie slices show how his wealth picture has changed. Now let's say he makes the purchase. So he's going to use his Venmo to pay the seller. So let's say his Venmo is attached to his checking account, so he can move $12,000 to buy this car. I don't know if he can actually move $12,000 with Venmo, but let's pretend that he can. So he uses Venmo to pay the seller, and the seller signs his title to the car over to him. Again, the total size of the pie has not changed, but the slices have. So savings didn't change, and cash didn't change, but his checking account went way down, and his property went up. So the way his wealth is distributed in these different storage modes is different, but the total amount of wealth that he has didn't change. Now, one thing that's different from this change to the last change is the last change, it was all his wealth moving around inside of his own wealth. Here, there's an exchange with somebody else. Some of his wealth actually left his pie, but some different wealth came in to his pie, and the amounts happen to be the same, so the pie size is still the same. Okay, now let's say he sells his old car. Now remember, it was worth $7,000, but he's going to try and help out his little sister by selling it to her for $5,000 cash, just because he's a nice person. So what happened now is he has lost some wealth stored as property, because he signed his title over to his sister, and he gained a smaller amount of wealth stored as cash. So in this change, he saw a net loss of wealth. Cash and property has changed, cash has changed, but savings and checking didn't in this case. But now if you look at the pie, his total pie is smaller because he doesn't have as much wealth as he used to. Essentially, he gave his sister $2,000 by selling his car to her for less than it was worth. Let's look at another change. Next, he gets paid by his employer. His employer transfers money into his checking account through a transfer that's known as an ACH. Now, in this case, his pie actually gets larger because his total wealth increased. His checking account gets bigger, everything else stays the same amount, but the total size of the pie grows a little bit because he got some money from his employer that he didn't used to have. Okay, so why is this useful? This has nothing to do with physics, but it does, because this is a metaphor, remember? And energy is a quantity like wealth, only it's for the physical world of objects interacting. So like wealth, energy is an ability. Like wealth is an ability to cause change in the economy, energy is the ability to cause change in the physical world, not the economy. There are two specific changes that energy can make in the physical world. One of them is energy can cause changes to the temperatures of objects. So things can get hotter, things can get colder as a result of energy changes. And the second one is energy can cause objects to move. It would be better for me to say energy can cause changes in the states of motion of objects. So if an object speeds up or slows down or comes to a stop or begins moving, those are all evidence that energy has exchanged in the universe. And those two types of changes, causing change in temperature and causing the motion of an object, pretty much covers everything that goes on in the physical world. Also, like wealth, energy can be measured. You may have heard people use words like BTUs, or kilowatt hours, or amp hours, or calories. Those are ways that we measure energy. They're not energy. They're just different units of measuring energy. Like dollars, or euros, or yen, or francs. Those are all units of measuring wealth, but you don't have to have dollar bills or euro coins in order to have that wealth. For now, don't worry about how to measure energy. We won't get that specific. Also, like wealth, energy can be stored in a variety of different ways. So we saw that wealth could have been stored in a checking account, savings account, as cash money, in property, like a car, but you could also store it in securities, you could store it in land, other kinds of property. So there's a lot of different ways that you can store wealth. Same thing is true for energy, and we're going to talk in a little bit later about different ways that we can store energy. And then lastly, energy can be transferred in different ways. In our example that we went through, wealth was transferred by an ACH, that's a kind of a wire transfer between banks. It can be with Venmo, with an app. You can hand somebody some bills. That's a cash way of transfers. When he bought the car and when he sold the car, a title was signed, and that's how wealth was transferred. So there's a lot of different ways to move wealth around. The same thing is true for energy. We're going to look at 3 specific ways that energy can be transferred. And wealth, well, there's quite a bit more than 3 different ways to transfer wealth around. Let's look at 5 different ways that energy can be stored that are pretty common in simple physical situations. One of them is called gravitational energy. Now, you may have in science classes before heard of this as potential energy, but all energy is potential, and so we're not going to use that word. We're going to try and avoid that. We're going to call this gravitational energy. This is energy that's stored in an object held away from the Earth. It's stored in the position of an object that's in a gravitational field. So think about a rock that's held above a tent stake. If the rock is dropped, it could cause the tent stake to move further into the ground. The ability to do that is energy. If that same rock was dropped from a higher height, it will cause more motion in the peg. So higher heights mean more energy stored as gravitational energy, or we're going to abbreviate this as EG for short. If you compare a heavier rock to a lighter rock, both drop from the same height, the heavy rock is going to cause the peg to get driven further into the ground. So a bigger weight, if the height stays the same, translates to more energy stored as gravitational energy. Another energy storage mode is something we call kinetic energy. This is energy that's stored in an object because it's moving. If a moving car smashes into a parked car, it will cause the parked car to move a little bit, change its state of motion. That ability to cause that change is energy. If that same car was moving faster, it will cause a bigger change in the motion of the parked car. So more speed means more storage of energy as kinetic energy, or EK we'll use for short. If a heavier car is moving at the same speed as a lighter car, it will cause more change to the state of motion of the parked car. So another thing that we know is more weight means more energy stored as kinetic energy. Another energy storage mode is thermal energy. This is energy stored in objects that are hot. So as the particles that make up the object start vibrating more and more rapidly, that random chaotic movement of those teeny tiny particles that are too small for us to see, that's a way of storing energy. If you place cold butter in a warm pan, the butter will become warm and it'll melt. That ability to cause that temperature change is energy. If the pan is hotter, the butter will melt faster. So the hotter the object, the more energy, the more ability to change is stored as thermal energy. If you have two pans that are the same temperature but one is much bigger, the bigger pan will melt the butter faster. So the bigger the object, the more energy is stored as thermal energy. And this is just because even though the particles are jiggling at the same speed that make up these two pans, there's just way more particles in the bigger pan. Another energy storage mode is called elastic energy. This is energy that's stored in things when they are stretched or compressed or squished. Think about a spring that's been compressed and has an object placed on it. If the spring is released, it has the ability to move the object, and that ability is energy. It changes the state of motion. Now, the more the spring is compressed, the higher it can launch this object that we see here. So the greater the compression, the more energy is stored as elastic energy. Now, this also works for stretching a spring. If you stretch a spring out, you also store energy. The more you stretch it, the more energy is stored as elastic energy. It's also important to note that many other things can store elastic energy than just springs. Some examples are rubber bands, bungee cords, a bouncy ball, pretty much anything that will change its shape by squishing it, stretching it, or bending it, and then it will go back to its original shape and release that energy. One final energy storage mode is chemical energy. This is energy stored so that it can be released in a chemical reaction. How this exactly works is complicated, and it's a topic for chemistry, an entirely different class. So we're not going to get into the details here. But for now, we can identify chemical energy has been released when we see one of three things: food, fuel, or batteries. And if you think about food, it's really just fuel for a living system. So these are three things. If we see those causing a change, we know that that's chemical energy storage. Before we leave, it's important for me to point out that even though I've been talking about these storage modes, gravitational, thermal, kinetic, elastic, chemical, as if they're different kinds of energy, that's not true. There's only one kind of energy. There's just energy. It's all the ability to cause change. It's just stored in these different ways. And so these five things, kinetic energy, gravitational energy, thermal energy, elastic energy, and chemical energy that I've been talking about, these are just storage modes for energy that can appear in a system.